So solubility, well, we already know water. So water's the universal solvent, right? If I ask, what is the solvent? What's a solvent? A liquid. What's a solute? Solid. Solute and solvent. So what is the universal solvent? That is water. Okay? That is water. And all right. Now, likes dissolve likes. Okay. That's kind of one of the bigger takeaways for today. Likes dissolve likes. Okay. So if they're similar, they dissolve each other. Now, what's that mean? Okay. Now, when we had salt and we put it in water, you stir it up, it dissolved, right? That's because both of those were polar. All right, they were both polar. Now, what happens when you put oil on top of water? They don't mix. Why? Oil is non-polar. You're exactly correct. Now, has anybody ever tried putting oil on top of water and adding soap? You have. What happens? Ooh. Should we try it? We should try it, I think. Do I have oil? We'll have to find out. It's a pretty interesting experiment. Let's see. Oh, absolutely. Just a little bit. Enough to get the job done. We'll take it. Always keep oil in the bag. Oh, yeah. Oh, vegetable oil. I was going to make some peanut butter fudge with this, but I got a better experiment to do. All right, so nothing like a little bit of water. So I got my water. I got my vegetable oil. Okay. Now, can everybody see that? You can see the two different layers, right? Honestly, I'm going to go one step further so you guys can see it. Oh, yeah. What color are we feeling? Red. Okay. We got some red in here. There we go. Come on, stir to the bottom. Okay. Break through, break through, break through. Just wants to sit on top. Okay, eventually those will sink through. And what we're going to do is we're going to put some soap in it. That's just silly. There we go. Just had to give it a little pressure. Okay, so the red soaked to the bottom and oil still on top, right? Now, when I put soap in, just some good old dish soap. I'm going to shake it up over the sink because, you know. I'm losing some of it. Outside of the bubbles, what you guys see? It all mixed together. It all mixed together. So what?
I think you poured out all of them.
No, I didn't. I got soapy on my hand. So, can anybody tell me why that worked? You are exactly correct. Soap is nonpolar and polar. All right, soap is both. All right, so it can adjust to the nonpolar, it can adjust to the polar, and it's kind of like holding them together. Kind of like holding them together, bringing them, bringing all the friends together, and that's what soap does. Okay, so likes dissolve likes. All right, now solubility. If you had to write down one definition, there it is. There it is. The maximum amount of solute that will dissolve in a solvent. Okay, if you write that down, probably a good idea. the maximum amount of solute that will dissolve in a solvent. Okay? So the maximum amount of solid dissolving in a liquid. Okay? That's what solute is, or solubility. Okay? That's good. All right? The maximum amount of solute that will dissolve in a solvent. All right? That's probably the biggest takeaway. Okay? Maximum amount of solute that will dissolve in a solvent. And that's pretty much all the only notes you're going to be taking today. Not too bad. Not too bad. Okay. Everybody good? So this is an example of a solubility curve. Okay. So this shows you how much solute can dissolve in a certain amount of temperature. Okay. So as temperature increases, what happens to solubility? It also increases. It goes up, right? It goes up. And that's how much solid you can dissolve in a liquid. Okay? Now, as I just said, as for a solid, solids go up. Okay? The solubility of solids go up. What do you think happens for gases? When temperature increases, what happens to gases? They go down. They go down, right? Because as the temperature increases, gases are going to be turned into gases, so they're not going to want to dissolve in water. Okay? So as the temperature increases, gases go down, solids go up. Does that make sense? I'm going to show you some examples here. I'm going to show you some examples. All right. That's a solubility curve right there. There's a lot going on right there, isn't there? Okay. Now, it says, show the amount of solute that can be dissolved in the given temperatures. Okay. What is the solubility of NH4 at 70 degrees? Now, what you have to do, all right, and we're going to be analyzing these, drawing these. We're going to draw one today, one tomorrow in our lab. NH4Cl. What you're going to do is you're going to find NH4Cl. Here's my line. There it is. Do you guys see that? NH4Cl. What is the solubility at 70 degrees? So what you got to do is find 70 degrees, go up to my line, which is NH4Cl. How many grams dissolved? 60. How'd you get that? You're exactly correct. 60 is your answer. Okay. 61. Just, all right. How many grams? Oh, let's see. How many grams of KNO3 will dissolve in 100 milliliters? So we need to find my KNO3 line. Let's see. Right here. Here's my KNO3. How many will dissolve in 50 degrees temperature? I got 50 degrees. There's my KNO3 right there. How much will it dissolve? About 80, 85 maybe? 83? Does that kind of make sense? All right, one last one. How many grams of KNO3 will saturate in 200 milliliters? Okay, this only has 100 milliliters. Ooh. Okay, so in the experiment we did, you guys wrote your own procedure. What happened when you added more water and stirred in the sugar? What happened when you added more water? Which one dissolved faster? The one with more water. It probably dissolved twice as fast. So what you're going to see is KNO3, that was this line. Well, we already have our answer for here. So 83 grams dissolved in 100 milliliters. How many do you think is going to dissolve in 200 milliliters? 166. How'd you get that? Yeah, it's twice the amount of water than this answer. So it's going to be the twice amount of dissolving. Well, 166. There you go. You're exactly correct. Does that kind of make sense? All right, I have one last thing I want to show you. Do you guys remember the difference of supersaturated, saturated, and unsaturated? That was Friday. Yeah, what's supersaturated?
All the dots, not
Ton of dots. You're exactly correct. What's unsaturated?
there's no dots.
Nothing. Absolutely nothing. You're exactly correct. What's the middle one? Yeah. There's like one dot, very tiny. Okay. Now, when we're looking at these lines, so we already got that. We already got those. When we're looking at these lines, anything above the line is going to be supersaturated. Anything exactly on that line is saturated, and anything below or under the line is unsaturated. Okay? So let's see an example of that. Oh. Can you guys read that? That's kind of small. It says if a solution contains 20 grams of NaCl. So I got to find my NaCl. Here's my NaCl line. Do you guys see that? So if it contains, let's see, 20 grams dissolved in 100 milliliters of water at 25 degrees. So there's a lot of things here. So 25 degrees temperature, 20 grams. Okay? Right there. Right there's my dot. Is that above or below my line? Below. Does that make sense? Would it be easier if I pulled this up and drew it? All right. So 20 grams. So here's my 20 gram line. Okay. 25 degrees temperature. So I got to see where those intersect right there. And then here's my NaCl line. Well, clearly that is below. So that's going to be what? Unsaturated. Perfect. You're exactly correct. Let's try one more. How many grams are there in a saturated solution of KCl at 80 degrees Celsius? So what we got to do is we got to find the KCl line. Here it is. There it is. 80 degrees temperature. Okay. Oh, that's not 80 degrees temperature. Monday. That's my Monday blues. 80 degrees temperature. How many grams are in a saturated solution? What would be your answer? How'd you get that? Yeah. So I went up to my intersection. Here's where they two meet. How many grams dissolved? 50. Okay. I think there's one more. How many grams are in a saturated solution of KCl at 40 degrees temperature? So once again, you probably start to see a trend. All right? You probably start to see it. Let's see, where's KCl at? What is it? Oh, why did I erase it? KCl at 40 degrees temperature. That's your answer. Does that kind of make sense? I know it's kind of a lot of new stuff. A lot of new stuff. All right. But that's how we're going to do solubility graphs. Okay. Is there any questions on that? Okay. So what we're actually going to do today is we're going to make our own graph. Okay. We're going to plot our own points. Right? Of 5 different substances. Okay. Then we're going to answer some questions on the back. Okay. On this, I actually want everybody to get a piece of paper so that you can graph it. However, if you'd like to work with somebody, that's fine as well. But I do want everybody to have their own. Okay. Let's see. So yeah, we're going to create a graph. Okay. And on the graph, what I want you to do is now you don't need to draw this. I already have the graph labeled for you. But you're going to have to go by tens. Okay, so you're going to go 10, 20, 30, 40, 50, etc. And then 10, 20, 30, 40, 50, etc. Does that kind of make sense? Okay. So we're going to try this out. Tomorrow, what we're actually going to do is we're going to create our own solubility curve based off of our lab results. Okay, so we are going to do a lab tomorrow. Make sure you wear shoes. All right. And we're going to analyze how effective solubility curves work. All right. So, if you guys have any questions, feel free to ask. All right. Fill in some of these definitions, or if you feel like you would rather draw, you can draw those, and then graph them. All right. I say to use different colors, so if you want to use different colors of pens, that is fine. However, I will put out my colored pencils so that you can graph using the different colors. All right. Like I said, if you would like to work with somebody, that is fantastic. We'll be good to go.
Come on, Jonathan. Oh, wow.
All right.